Hello friends, this video we are going to see what is the Parseval identity of Fourier transform, then using the Parseval identity how to find the improper integral. We are going to see in this video. So first we state what is the identity of Parseval identity. Let f of omega and g of omega be Fourier transform of absolutely integrable function piecewise smooth function so namely we call as f and g respectively. Then so we have the two, that is first one is integral over minus infinity to plus infinite f of omega times g complex constant of g of omega times if we integrate with respect to d omega equal to 2 pi times integral over minus infinity to plus infinite f of x times g of x complex conjugate dx. Suppose g is real, that is complex conjugate become g of x only. So this one, and suppose f of omega equal to g of omega and f of x equal to g of x, then that is our second identity, integral over minus infinity to plus infinite, that is spectrum energy. We already know that f of omega absolute value square is energy of the spectrum of f. We already seen this is equal to 2 pi times integral over minus infinity to plus infinite absolute value of f of x square dx. So these two are the important Parseval identity. I will not going to give any proof. I am going to using the Parseval identity how to solve the problems. So first we start with the problem. Let's say example 1. Find the Fourier transform of block function so that is rectangular impulse function it is f of x defined as f of x equal to 1 whenever x lies between minus a by 2 to plus a by. So that meaning is then 0 otherwise. Then evaluate integral over 0 to infinite sin square x divided by x square dx. I want to evaluate this integral. So, what is mean by mod x less than a means? This meaning is x lies between minus a to plus a. Okay, that is the meaning. The reason is it is centered at the x is the center at origin, the radius is a by 2. So, these are my a by 2 minus a by 2, this is plus a by 2, this is my radius, that is a by 2. Okay, now I am going to find this. First we want to find the Fourier transform of the f of x, then evaluate this integral. So, first f of omega equal to integral over minus infinity to plus infinite f of x exponential of minus I omega x dx. This is the definition of Fourier transform. So, our function is only has the support on minus a by 2 to plus a by 2. So, our integrations become integral over minus a divided by 2 to a divided by 2, only the function has the support, times 1 exponential of minus I omega x dx. If you are integrated, you will get it as exponential of minus I omega x divided by minus I omega minus a divided by 2 plus a divided by 2. This is nothing but you will get it as 2 times sin a omega divided by 2 divided by omega, provided omega is not equal to 0, because denominator is 0 is not meaningful. Okay, so now I find what is the f of 0. So you can do it, limit x tends to omega tends to 0, it's become a, you automatically know that, otherwise you can calculate from the Fourier transform also. So then your integration become integral over minus a by 2 to plus a by 2 1 times exponential of minus I 0 times x dx. So this guy is become 1. If you are integrated, you will get it as x minus a by 2 to plus a by 2. So you will get the answer is a. So this implies f of omega equal to 2 times sin a omega divided by 2 divided by omega a. This is omega is not equal to 0, here omega equal to 0. Now I am going to find evaluate this integrals, correct? My aim is I want to evaluate the integral using the Parseval identity. So what is the, first we recall our Parseval identity. What is the Parseval identity? Says integral over minus infinity to plus infinite absolute value of f of omega square d omega equal to 2 pi times integral over minus infinity to plus infinite absolute value of f of x the whole square times dx. So what is the left hand side? So my f of omega is, because I take the omega is not equal to 0, so then our limit process also we can write the same thing only. So okay, we can write as 4 sin square a omega divided by 2 divided by omega square d omega equal to 2 pi times integral over minus infinity to plus So you can take this one is minus a divided by 2 to plus a by divided by 2. The reason is f is support only between minus a by 2 to plus a by 2 only. So 1 times square is also 1, so dx will come. So now our integration looks like the same thing only, but the problem is here a omega e is sticking because we require. So then I will change this one equal to 2 pi times a. This is f of 0 we already calculated, that's why I didn't do much calculation yet. My right hand side, my left hand side is only trouble because I want to change this as a some single quantity. So now I take my left hand side as I. So I equal to integral over minus infinity to plus infinite sin square a omega by 2 divided by omega square times d omega. So now I take u equal to a omega divided by 2. This implies du equal to a divided by 2 times d omega. This implies d omega equal to 2 divided by a times du. Then u tends to minus infinite. Sorry, omega tends to minus infinite. This implies u also tends to minus infinite because a is some positive quantity. Omega tends to plus infinite, u also going to the plus infinite. Now you look, my I equal to 4 times minus infinity to plus infinity because limit doesn't change, sin square a omega divided by 2 is u divided by omega equal to 2 divided by a the whole square times u square. D omega is 2 divided by a times du. Now you look, the denominator, this 2 square is 4, this guy and this guy will cancel out each other. So our integrations become, now you will get it as 2 and here is you will get it as a, this a and this a will cancel. So 2 times a integral over minus infinity to plus infinite sin square u divided by u square times du. So this integral only I want to evaluate. So from this results, now I take, namely this is equal to some equation number a. From a, integral over minus infinity to plus infinite 2a sin square u divided by u square times du equal to 2 pi times a. That is, we already evaluate. So now you look, this a will cancel and this 2 and this 2 will cancel. But our integration is, our aim is I want to find the integration of 0 to infinite. So the given function is a even function and these are the, so using this fact I can write it as, this integration is 2 times integral over 0 to infinite sin square u divided by u square times du equal to pi. This implies integral over 0 to infinite sin square u divided by u times du equal to pi over 2. So we evaluate the integral over 0 to infinite sin square x divided by x square dx is pi by 2. I hope